Glass, a material that feels so familiar, it's almost invisible to us. It's present in every corner of daily life, from the simplest bottles and jars to the transparent panels in windows, smartphones, and cars. But have you ever stopped to imagine that all of these things are actually born from something as ordinary as tiny grains of sand? Every year, more than 60 million tons of silica sand are extracted, and these silent grains begin a powerful transformation inside high-tech factories. They are heated, shaped, and refined in ways you may have never seen before. So right now, join me as we step inside the largest glass factory in the United States to discover what truly turns invisible sand into the solid, sparkling pieces of glass that shape our lives. History of glass. Did you know that glass was discovered completely by accident over 2,000 years ago? Around 300 BC, ancient Egyptians were heating silica sand mixed with sodium carbonate near an open fire. Without realizing it, they ended up creating a solid, transparent material that had never been seen before. Since then, glass has quietly become part of our everyday lives. It's in windows, bottles, drinking glasses, phone screens. What makes glass so unique is its internal structure. It's transparent like crystal, but also incredibly resistant to heat, corrosion, and even electricity. And perhaps most impressive of all, it can be recycled again and again, without losing quality. But here's the paradox. Despite its strength, glass is also fragile. Unlike metals or plastics, it can't bend or stretch when pushed beyond its limits. It doesn't deform, it shatters. Pretty strange for something that's all around us, isn't it? First, let's take a look inside a glass bottle factory, where ordinary grains of sand go through a truly astonishing transformation. Sand mining. Yes, glass is made from sand, but not just any sand will do. Only the most extremely pure sand with silica content reaching up to 99% meets the strict standards required for glass production. This kind of high-grade silica sand doesn't come from beaches or deserts. It's typically extracted from massive open-pit mines where industrial explosives are used to break apart dense layers of rock that contain silica. After the detonation, massive excavators scoop up the shattered rock and dump it into heavy-duty trucks. These trucks transport the raw debris to a crushing facility where powerful industrial mills grind the material relentlessly into uniform grains of fine sand. This finely ground silica becomes the essential foundation for the entire glass manufacturing process. Although the sand has already been crushed, it still hasn't reached the level of purity needed for glass production. That's why it moves into a modern washing system, capable of processing up to 220 tons of sand per hour. The process begins as trucks discharge the crushed material into a large hopper, which feeds into a regulated flow system. The first checkpoint is a primary sieve, fitted with precision meshes, such as 30 mesh screens, meaning 30 holes per square inch, to filter out oversized particles. Only the finest grains meeting the required specifications move forward into powerful agitation chambers, where they're thoroughly cleaned using high-pressure, needle-like water jets. After nearly 15 minutes of continuous agitation, the water-sand mixture begins its controlled descent into a spiral separation system. Here, centrifugal force comes into play. Heavier metallic particles are pushed outward and gradually filtered out. The remaining stream, now lighter and more refined, moves toward a mechanical separator designed to capture any remaining traces of iron. Once the sand is dried, it's loaded into 1-ton bags and shipped to the glass factory. Glass bottle factory. It is the largest glass plant in the United States, which receives more than 5,000 tons of silica sand each week. In addition to the sand, sodium carbonate and calcium carbonate are mixed in. These components alter the structure of the silica, helping to lower its melting point and making the entire mixture easier to fuse. Calcium carbonate also contributes to improving the durability of the finished glass. To add color, specific pigments are introduced, such as cobalt oxide, which creates the distinctive blue hue in certain types of glass. Once all the ingredients are prepared, they are poured into a filtration system to eliminate any final impurities before entering the actual production process. The materials, once filtered, are transported by a belt system of conveyors to the mixing area. These conveyor belts are capable of moving hundreds of tons of sand per hour continuously without interruption. In the mixing zone, the sand enters high-speed stirrers, where each particle is evenly blended and subjected to a deep cleaning. This process ensures that any remaining impurities still clinging to the surface of the silica grains are thoroughly removed. The resulting mixture is then transferred into a massive gas furnace, where temperatures soar to 1,650 degrees Celsius, hotter even than molten lava from a volcano. Technicians carefully monitor the process and pour the mixture into special crucibles. Once the materials are stabilized, the mouth of each crucible is sealed to maintain the high temperature and control the fusion process. Inside the facility, workers must wear fireproof suits and Kevlar gloves as the surrounding heat is incredibly intense. After 24 hours, the mixture is no longer sand. It begins to flow like lava. What glows at the bottom of the furnace is liquid glass, a dense, glowing mass that has reached the perfect temperature and viscosity for several more hours. The glass remains in a molten state to allow for any remaining gases to escape, ensuring the highest level of purity in the final material. The next stage of the process is mold creation.
Engineers first use specialized CAD software to design the mold with high precision, ensuring that every detail, dimension, and thickness meets the required specifications. The digital design is then transformed into a heat-resistant metal mold, ready to receive the molten glass that will be blown inside. Once the molds are finalized, they are installed into the double-blow production line, one of the most widely used methods for shaping hollow glass items, like soft drink bottles, food jars, or pharmaceutical containers. The process begins by releasing drops of molten glass, known as gobs, into the preliminary mold. These gobs are cut from a continuous stream of liquid glass, reaching temperatures up to 1,100 degrees Celsius and possessing the ideal viscosity for smooth shaping without excessive deformation. Inside the preliminary mold, a jet of compressed air is injected from above, forcing the hot glass outward against the mold walls and shaping an initial form known as a parison. This early shape resembles a hollow bubble with a narrow neck. Still glowing with heat, the glass is gently moved to the final mold, sitting just inches away. Here, a second burst of compressed air is shot into the center of the parison, stretching the soft glass outward until it hugs every detail of the metal cavity. In mere seconds, the full shape of the bottle is born. It may seem quick, but behind the scenes, every valve and sensor is timed with stunning precision, synchronized down to 1,000th of a second. That level of control is what makes it possible to produce hundreds of thousands of bottles a day, each one nearly flawless, like it came from the same perfect mold. Fresh from the oven, the glass bottles glow red hot, their surfaces shining in the dark like molten iron rods. One by one, robotic arms glide into position with graceful, carefully programmed motions. They gently pick up each bottle and place it onto the moving conveyor. No rush, no noise, just flawless coordination. The conveyor belt gently moves the freshly molded bottles, still glowing red at the base, toward the cooling zone. They enter a long yellow tunnel where the temperature drops gradually, step by step, allowing the glass to settle without cracking. This slow and careful cooling process isn't rushed. It can take several minutes, sometimes even tens of minutes to complete. As the journey continues, the now cooled glass bottles enter the inspection zone. Here, a network of optical sensors and high-speed cameras constantly scans every bottle in real time. Any flaw, whether it's a crack, bubble, scratch, or slight deformation, is instantly flagged and removed from the line. Next comes a detailed check of the bottle's mouth. An advanced automated system carefully rotates each bottle, while optical sensors and mechanical probes work together to spot issues like chipped rims, hairline cracks, or even the tiniest error in size, ensuring only flawless bottles move forward. Then the glass bottles that have successfully passed all inspections are transported to the palletizing area, where a team of automated robots takes over. These machines are responsible for arranging thousands of bottles with remarkable precision and consistency. Using a clamp system equipped with suction cups, they lower down, lift an entire row of bottles at once, and place them gently onto pallet layers. Between each layer, a protective sheet is added to prevent impact damage during handling or transport. Once stacked, the pallet blocks are tightly wrapped in film by an automatic machine and labeled with a code that matches the production batch. Every step of this process is carefully overseen from the central control room, where operators monitor key parameters in real time to make sure everything meets quality standards before the bottles are stored or shipped out to their final destinations. Sheet glass factory. Next, we head to a flat glass factory where absolutely nothing goes to waste. 100% of glass scrap is recycled here. Massive piles of broken glass shimmer under the sun, forming sparkling hills that stretch across the yard. All of this discarded material will soon be melted down and reborn as new glass panels, ready for another life. Fragments are collected and poured onto a conveyor belt, where they're blended with pure silica, sand, and other supporting materials like sodium carbonate. This careful mix not only recycles old glass, but also lowers the melting temperature required, significantly reducing energy consumption throughout the entire production process. Once the mixture of pure sand, sodium carbonate, and recycled glass is fully blended into a uniform mass, it's sent into the fusion furnace, an enormous thermal chamber that runs non-stop at temperatures close to 1600 degrees Celsius. Inside, the material slowly melts over the course of a full 24 hours, allowing every component to fuse completely. The result is a steady, uninterrupted stream of molten glass with exceptional clarity, consistency, and viscosity, ready for shaping into flat panels. After the fusion stage, the molten glass isn't shaped by blowing like in bottle production. Instead, it goes through the float method, a specialized technique used to make flat glass. In this process, the hot liquid glass is gently poured in a continuous stream onto the surface of a molten metal bath, typically tin, because of the difference in density. The glass floats and spreads out naturally, leveling itself into a perfectly flat sheet with parallel and incredibly smooth surfaces. As the glass flows forward, it gradually enters zones with carefully controlled temperatures, allowing it to cool evenly without warping, preserving its flawless shape and crystal clear appearance. As the glass sheets leave the tin bath, they move forward on a long conveyor system, still holding on to a gentle warmth from the earlier stages. At this point, precision takes center stage. Robotic arms pre-programmed to exact specifications glide into action using diamond-tipped blades or laser tools to cut the glass. Each slice is executed with incredible speed and accuracy, ensuring clean edges without causing cracks, chips, or surface stress.
Preparing the sheets for their final dimensions with surgical finesse. After the sheets are cut into individual panels, their edges remain rough, often uneven or sharp, which doesn't meet aesthetic standards and poses safety risks. To fix this, each panel is sent to a specialized edge polishing machine. There, high-speed abrasive wheels or rotating blades go to work smoothing every side with consistent pressure. This process rounds out the corners, refines the shape, and defines the edges with pinpoint precision. The end result is a glass panel with exact dimensions that's not only visually clean, but also safe to handle, transport, and install in its final setting. Once production is complete, some glass samples are taken to a testing room to check their hardness and impact resistance. During these tests, if the glass cracks in a spiderweb pattern but doesn't shatter into sharp, dangerous pieces, it's considered safe. This type of breakage means the panel meets established safety standards for everyday use. Finally, the glass panels that pass all quality checks are carefully lifted by robotic arms and stacked neatly on specialized racks. Between each sheet,
protective layers are placed to prevent scratches or impact damage during handling. Once secured, the entire stack is moved to the loading area where it waits, ready to be shipped out and distributed to factories, construction sites, or stores around the world. Conclusion. So you just joined us on an incredible journey through the world of glass, a path shaped by heat, precision, and human ingenuity. From glowing fragments to flawless panels, every step reveals a story of transformation and craftsmanship. If this behind-the-scenes look sparked your curiosity, don't forget to hit that subscribe button. We've got many more fascinating processes and untold stories waiting for you. Stick around, keep exploring, and we'll see you in the next video where ordinary things become extraordinary when you look a little closer.